So in a previous video, we took a look at this scope that I've got on the turntable here. It's a UEI Oscilloscope Model 301. When I received it, there were several issues. Several of the caps underneath had broken loose just through mechanical shaking or impact. There was a lot of just old components here. I pulled out a couple of wax caps. I've got one of them here, 0.1 microfarad 600 volt wax cap. There's another one laying on the bench here. I probably should have shot a bit of video of me replacing these, but I didn't. I've gone in and replaced a few caps. Of course, these yellow ones here are replacements. This guy's a replacement. I didn't have, thought I had ordered electrolytics to replace these three, but I don't have them. It feels slightly magnetic. That's weird. Kind of looked over all the solder joints. This was definitely a kit that was put together somewhat clumsily, but it is what it is. Checked all the lead clearances. I've shot some deoxit into the pots and switches and cleaned them up. It's still got this mechanical alignment issue here where the shaft of this pot rubs against the case. I don't really want to tear it down mechanically that far, but I'm at a point where I think I'm gutsy enough to put power on it and see what we get. So here we go. I'm going to plug it in. Make sure we're recording here. Let me kind of recenter the camera here. We'll bring on the power at the minimum intensity and see what we get. I've got heaters in the tubes that you probably can't see. I don't know if you can see the heater back in there or not. It's probably not, but I've got heaters in both tubes. I can see heater down in the neck of the CRT. It's a good thing. Let's bring the intensity up. I have taken all the controls to the left limit. Let's center these out. Oh, well, that's a really good sign. We have a trace. I don't know what vertical is. Maybe sensitivity, sync, sweep, horizontal. There's horizontal sizing. Like a little better focus. Focus isn't very linear across the sweep, but that's about as good as the focus is going to get. Let's see. Well, that's varying the sweep speed. As is kind of predictable by the design, it's pretty I don't know if that's the vertical amplifier or not. It does have an XY mode. That's why I was interested in it, because I really wanted to play with it in XY mode. That pot is still pretty dirty. Horizontal width. Pots are very loose inside. Well, isn't that interesting? Maybe it's time to feed a signal into it and see if it'll actually display something. Let me find a lead here. So of course something I need to be kind of sensitive to here is grounding. I don't want to blow up one of my instruments. I'm pretty sure this isn't a hot chassis. It's not. I should really dig out an isolation transformer just to be absolutely safe. I'll be back. So back here in the back is an isolation transformer, 115 volt primary to 150 volt secondary, 250 volt amp. Got it at a yard sale. Or maybe an estate sale. It was very inexpensive. I want to say $10 or less. Again, I see that kind of stuff, you just snatch it up. So scope is into the isolation transformer. And then we're now electrically isolated from the grounds. I can fire up my function gen. I want to get on channel 1. And we're producing a 1 kilohertz sine wave. I'm going to assume, that's a poor assumption. See if I can clip onto here. So there's the input. And the ground does run actually to chassis, so I can connect a chassis for ground. So we'll do this from the front. Oh, that doesn't actually rotate. I assumed it rotated so you could screw something in behind it, but I guess not. So it just wants a little post poked in there. You can certainly reference the chassis there. Let me figure out if I got a little piece of wire or something I can use to get a connection down into that input. Never a piece of wire laying around when you need one. That's going to be too loose. Way too loose. Well, I'm just going to clip directly onto the capacitor back in here. The DC blocking capacitor that comes up to here. Output 1 is on. We're firing out a 1 kilohertz sine wave at 5 volts peak to peak. Heaters are coming up. Well, that's not a particularly good sign. Oh, there it is. Nice. Let's vary the sweep speed. Of course, I don't have any synchronization set up. Oh, that's nice. Let's see, horizontal. Can I spread that out? Well, we know both the vertical and horizontal sweep works. We've definitely got a sine wave on there. It's nice and noisy, moving around, but what do I expect from a very inexpensive toy like this? Get it sync a little bit. Oh, it actually does seem to have a sync control. Interesting. Hopefully those electrolytic caps are going to hold up through this little demo. Yeah, isn't that fun? You find another cable here. You know, you never have the cables you need. Never have them handy. Oh, come on, I know it's laying right here. Okay, we'll grab another one. I want to feed it a signal in on the vertical as well. Power it off, we should be able to make the same electrical connections underneath. We'll come to chassis ground again, and the vertical input doesn't seem to be DC blocked. That's interesting. That doesn't seem to be blocked through a cap of any kind. See if I can get a mechanical connection on there. Hopefully these will stay on while I bring it around here. Go to channel 2 if I can remember how to swap to it. Channel 2's got a 1.5 kilohertz, 5-volt amplitude. We'll fire it up as well. We'll go to external input. Heaters are coming up. Hopefully my arm's not in the way here. Horizontal in. There's what I was looking for. There's what I'm trying to do. Boy, is that broken up. That should become the new logo for my tube, or my channel. Looks like a little alien. I suspect we've got capacitors that are unhappy. I don't want to run this too long. Oh, I bumped it, and why did I lose the horizontal sweep? Vertical. Vertical size. There it is. Dirty pot. Even though I cleaned these. Bring it back up towards center. Draw a circle, 1 kilohertz. Well, that's the best circle we can get out of it. It's certainly not much of a circle. These pots are very loose inside. Go back to channel 1. Go 90 hertz. Oops. Frequency 90 hertz. It's a little bit like what we should be seeing. Yeah, this pot is definitely unhappy. Oops. Grabbed the focus by mistake there. Channel 1. Channel 2. Actually, what did I do there? 120 hertz. Now on channel 2. 180 hertz. Now this certainly needs more work. One of these pots is really unhappy. That's actually looking a little more like it should look. There's my problem. I was set to external sync. Let's go back, try a circle. Channel 1, 180 hertz. Alright, let's try and got sync. See if I can bring down the. Where's the horizontal? Can I bring down the vertical size? There it is. That's much more what I was expecting to see. And don't know if we caught that, but the magic smoke has just been released. Nice and stinky. Capacitor is still boiling. I'm sure it was a cap that gave loose. And of course, immediately powered it off and unplugged the power to the isolation transformer. I've now unplugged it from the isolation transformer. It sounded to me like an electrolyte cap giving up the ghost. Oh yeah, there's electrolyte on the turntable. So let's take a look at what just happened. No surprise that this gave up the ghost. It's actually nice to have caught it on camera a little bit. This guy right here, it's dripping out of him. He's definitely wet. He got very warm. Yeah, you can't lay your finger on him hot. No surprise. Got to be careful here. There's still potentially high voltage in some of the cats, but yeah, this electrolytic right here gave up the ghost. He's very warm. I'll spin this around to the front. There's a couple of drops. I don't know if you can see them here of electrolyte on the turntable here. Let's go ahead and find a paper towel and wipe that out. I just thought I'd find a paper towel and wipe that up. Well, it's always fun to catch a failure on the camera. I knew I was pushing it here. Just with those ancient electrolytics that we knew were failing. Yeah, I still can't find some paper towel. Be back in a second. So, get that up before it hardens up on there. That was rather exciting, wasn't it? I've actually got two 10 microfarad 450 volt caps I could swap in for that. I didn't order enough to replace all of them. That was certainly an unhappy capacitor. I'm going to go ahead and just plain remove him. Hopefully some of the noise got picked up. Ooh, he's still very warm. Let's see if I can walk him out of there. Ow. Ooh. Still too hot to handle. Well, we saw the way the screen was dancing. We knew something was getting into trouble. So it's a dual 8 microfarad, 450 volt. You can kind of see here on this end where the electrolyte has leaked out and failed. Again, honestly, no surprise that that happened. No surprise at all, honestly, that happened. Well, while we got it here, we'll swap in the two replacement electrolytics I had. Assuming I can get this insulation to cut off here. There's one trim down. Sad part, I just ordered some capacitors for another project. I didn't think to look to see if I had enough to finish this. Would have been nice to get those all in the same order. This is just a ground lead here. And here in a bag is these guys, and of course they are not the best replacement caps I should have for this. These are 10 microfarad, 450 volt, but as you can see, they are polar lead, not axial. Axial would of course have been much better in this application. Tie the two grounds together. Soldering pencil is heating up. Get this wrapped onto here. I've got plenty of length. Get to those other leads. In the case of the dead one, both the outcoming wires were red, so I'm assuming those are positive and the black is negative. I guess that's a safe assumption. Sorry about the helicopter outside. I'm still ventilating the wonderful smell of frying capacitor. As you can see, I'm not quite doing the same quality of work that Mr. Carlson does. But so be it. Lots of hazardous voltages underneath this thing. And I'm just merrily poking my fingers away in it. Not liking how that's feeling. That's what I was afraid of. That'll actually, will both of these reach to go directly? No. Where that one can be sent directly in and soldered there without the extension. Assuming I can get this lead out of here. Sit there, we will Add in some fresh solder. Get that post nice and reflowed. This one's going to require the little jumper lead. Which I started to wrap together here earlier. Having no luck getting those to wrap together. Certainly not the prettiest repair I've ever done. No shorts, plenty of clearance to everything. Well, we can try this again. Let's see, this is channel 1. Channel 2, actually. In here and get it back up. This is channel 1. And we'll try this again. Isolation transformer plug back in. I would expect one of the other caps to fail as well. Hopefully it won't be loud and explosive, but oops, turn the function generator off. Well, I have heaters again. Let's go 60 hertz. Channel 2, 60 hertz. Enable the outputs. Work on sizing here. I would have expected that to be much cleaner than that. Although as you can see, the display is much more steady. It's not dancing around there as much as it was before. Let's see, amplitude. Let's kick up the amplitude. Oh, can't go that high. Channel 1, amplitude, bump it up, say 6 volts. That is not what I wanted. Now I'm on triangle wave. There's part of the problem. Am I still recording? Good. I knuckled one of the switches on the function gen. I have one of the channels apparently in triangle wave. So there's 1 kilohertz. Should be 5 volt peak to peak. 1 kilohertz. Sine wave, amplitude 5 volts peak to peak. Let's enable the outputs. That's much more what I expected to see. I don't know how good a circle we can actually get here. I'm not going to be able to get it to round. Let's take it down to 120 hertz. Channel 1 and 120 hertz on it as well. Frequency 20 hertz. Of course, the same as we had before. It's poor circle. So let's go to channel 2. There we go. And 20 hertz on channel 2 and 120 hertz. 5 volt through there. It's a much better circle. This is again me munging around. Well, that's a reasonable circle, wouldn't you say? Now let's play with it. Channel 1, frequency, do 12 hertz. We should get a nice U, which we do. We should get another circle. It's a pretty bad one, but it is a circle. Go back to channel 1. Nice low frequency. That's a little too low. Back to 60 hertz. Channel 2. 6. Oh, damn it. Channel 2, frequency 60 hertz. Kind of back to a circle, kind of not. And there's part of the problem right there. Get a pretty flat line across channel 2. On channel 1, where that should just be a straight vertical line, it's rotated to a funny angle. It's the first problem. It's got a little bit of a, see if I can get it to, Well, as you can see, I'm not having a lot of luck all of a sudden here. Obviously driving the amp into saturation. Well, as you can see, it's a funky little scope. Anyhow, I'm going to wrap this up at this point, and we'll talk soon.